Good morning. Myself Sreelatha. Today I will discuss about basics of microprocessors and microcontrollers, the difference between both of the microprocessor and microcontrollers. So let me define microprocessor. Microprocessor is defined will be in different types. So first of all, it is a small chip part to control functions of digital systems like musical players, electronic calculators, computers, and others. This is one way. A microprocessor is a component that performs the instructions and tasks involving computer processing. So whatever the task will be performed, that will be based upon the instructions what we are given. So all this will be performed in the computer. It is one of the definition. This is the easiest way. Another one, an integrated circuit that contains all the functions of a central processing unit of a computer. It is nothing but definition of microprocessor. Simply CPU itself we can call it as a processor. Let's go to the next slide. This is types or evolution of microprocessor. It is divided into 5 generations normally. The first generation is nothing but is developed by Intel company. In the year 1971, by Intel company executed the first microprocessor, implementing the first microprocessor is nothing named as 4004. It is a 4-bit microprocessor. It is upon a clock speed of 740 kilohertz. And coming to the second generation microprocessor, in the year 1976, it's developed by 8085. It is the 8-bit microprocessor. Compared to the first generation 4-bit microprocessor, it is very efficient, and it will be implemented in Motorola and Intel 8085 company. And now coming to the third generation microprocessor, it is developed in the year 1978 by Intel company. During this year, 16-bit microprocessors are created and designed by using HMOS technology. Compared this third generation microprocessor, second generation microprocessors are used now 8085 as the 8-bit microprocessor. And here we are using here as a super fast and costly, and it is purely based on NMOS technology fabrication. And coming to fourth generation, in the year 1986, fourth generation was developed. It generates the 32-bit microprocessor by the company of HCMOS fabrication by using Intel and Motorola companies. And we can design here millions of transistors. High CMOS fabrication means we can design here millions of transistors. And coming to the fifth generation, in the year 1995 to until now, this generation has been bringing out the high performance of processors that make use of 64-bit microprocessors with the help of this Pentium and dual and quad core processors with operating with a clock speed of 3 gigahertz. So these about microprocessors has become more essential part of many gadgets. Gadgets that has been divided into generations here. Those generations are nothing but first generation, second generation, third, fourth, and fifth. Based upon these generations, we are using the second generation is nothing but 8085 processor, which is a 8-bit microprocessor. Which we are using is nothing but super fast. It will be super fast, costly, and here we are using the NMOS fabrication technology. So that belongs to the second generation of family. Coming to the next slide, it's nothing but this is the microprocessor based system with bus architecture. It consists of input, output, and microprocessor is nothing but ALU, resistor array, and control unit. Microprocessor itself, CPU itself, we can be called as a microprocessor. CPU itself can be called as a processor. Is nothing but CPU is the heart of the processor here. Simply, we can say that CPU is the heart of the processor. This microprocessor block itself contains ALU, resistor array, and control unit. So three will be this. The microprocessor segment is divided into block is divided into three segments. First ALU, register array, and control unit. So these are the three segments. And let me discuss the input device, output device, and memory. So this is the microprocessor based. This is a simple diagram related to the microprocessor. This is nothing but microprocessor based system architecture. This itself, microprocessor itself called as CPU. It is divided into three segments: ALU, register array, and control unit. And input-output devices will be there. Can also be called as peripherals. And here system bus will be there. And memory. Memory is nothing but contains two ROM and also read-write memory. Here it is a microprocessor is a programmable multi-purpose register-based electronic device that reads binary instructions from storage device called memory. It accepts that binary data as an input and process the process data according to those instructions and provides the result as output. Microprocessor contains millions of tiny components like transistors, resistors, and diodes to work all together. Let me discuss each one separately. Coming to the microcomputers is nothing but microcontrollers. As microcomputers have smaller instruction sets and are slower than many computers, but then they are very less expensive and smaller too. See here, input, output, microprocessor, memory. Here also same, but internal and external connections will be different. This microcontrollers is nothing but here it is the embedded systems is the heart of this CPUs. Embedded systems is the heart of the microcontrollers here. In microprocessors, we are using CPU itself is nothing but heart of the processor. And here, embedded systems is the heart of the CPU. So this is the difference between controllers and processors. Here also we are using the examples. We are used in several electronic gadgets. The examples of microcontrollers are nothing but oven, refrigerators, washing machines. All those are examples for microcontrollers. Let me discuss one by one. Arithmetic logic unit is nothing but central processing unit. Central processing unit, it performs some necessary arithmetic and logical operations. It's nothing but arithmetic operations means addition, subtraction, multiplication, division, all those things. And logical operations means and, or, not, compare, rotate, all these operations is nothing but logical operations. It performs both the arithmetic and logical operations, CPU. Coming to the IO devices or peripheral devices, input devices are used for feeding data into the CPU. The examples of these devices are toggle switches, A to D converters, keyboards, mouse, disk, card readers, etc. Simply, we are giving the input to the CPU in the form of text. These are some examples of input devices. The hardware used to enter data and instructions by the user. That is, the input information is in the computer. It is in the form of keyboard, mouse, scanner, digital, all those. Coming to the output device, the output devices are used for delivering the results of computations to the outside world. Communicate to the outside world. Examples are LED, CRT, DTA converters, printers, plotters, communication lines, etc. All those are examples of output device. So we will display the output here by using this device. Memory. It stores both the instructions to be executed, either the data or program. It usually consists of RAM and ROM. RAM is nothing but random access memory. ROM is read-only memory. So RAM means we are using here read or write memory to store the program and to store the data to execute that within the memory by using with the help of the processor. So ROM is a is used for permanent storage of data, and RAM or read or write memory is used for temporary storage of data. This is the difference between ROM and RAM, which will be storage of instructions within the program of memory locations. So these are some examples of output devices: printer, scanner, speakers, all those. Now, Coming to the differences, microprocessors and microcontrollers. So microprocessor is nothing but, see here microprocessor, the blocks using here microprocessor, timer, input output port, serial interface, read or write memory, read only memory. And this is nothing but CPU itself can be called as is the heart of the computer here. And here the blocks we are used microcontroller, read only memory, read write memory, IO, timer, serial interface. Here we are not giving any internal connections here. This is the blocks obtained in microprocessor and microcontroller components. Next, microprocessor is heart of the computer system, and here microcontroller is heart of embedded system, as we discussed earlier. Microprocessor, it is just a processor, memory, and IO components have to be connected internally. The components has to be connected internally in the circuit here. Here, microcontroller has sectional processor along with internal memory and IO components. Here, memory and IO has to be connected externally because the circuit becomes large. Here, memory and IO are present internally because the circuit is small. In microprocessor, it cannot be used in compact systems and hence it is inefficient. In microcontroller, it can be used in compact systems and hence it is an efficient technique. Microprocessor, the cost of the entire system will be increasing. Here, the cost of the entire system is low. Due to external components in microprocessor, the entire power consumption is high. Hence, it is not suitable to used with devices running on stored power like batteries, all those. And coming to the microcontroller, it is also used some external components are low. Total power consumption is less and can be used with devices on running on stored power like batteries. So here microprocessor, most of the microprocessors do not have power saving features. And here in microcontrollers, most of the microcontrollers have power saving mode like idle mode, power saving mode, etc. This helps to reduce the power consumption even further. So these are the differences between microprocessor and microcontroller. Thank you.